Hi everybody, so look, we're going to continue on with our organic synthesis for bite-sized chemistry, and this time we're looking at 2010. So look, we'll get straight into it. 2010 part A. Now, A is asking us to name the molecule in the scheme that contains no tetrahedral carbon atoms. Okay, so that means there is no tetrahedral carbon atoms in it at all. Okay, so let's go through it. It's going to have to be small. And again, we can, if you think about it, okay, in terms of your families of organic compounds, you notice there that the chloroalkanes and the alcohols, they're all tetrahedral. Okay, so they're fully tetrahedral, whereas everything else is what's the word I'm looking for, is planar somehow. Okay, so with that in mind, PVC we're going to ignore because we're not really told the name of that just yet. But C2H4 or C2H6, now it says name the molecule, indicating that's just a 1. So if we draw out both of those, and that's, for me, that would be the easiest way of going about it, to draw out both of them. So for A, I'm going to draw out both of them, I'm going to draw out one of them in a second. C2H4, and we know, I automatically know that's an ethene molecule because it contains twice as many hydrogens as the carbon. And there's 2 carbons, so therefore it's going to have to be ethene. And if I do that out, without doing any more, I can see straight away that there are no tetrahedral carbon atoms in this one over here. For instance, if I drew out the other one, C2H6 again has to be an alkene because there's twice as many hydrogens as there is carbons. So I'm just going to put in C2H6, I should say, is an alkane. I thought that was C3. Excuse me. So I'll do my C2, I'll draw it again. C2, and if I draw it out, I'm not putting hydrogens there, but you can see that there are no tetrahedral carbon atoms. Sorry, that there is a tetrahedral carbon atom. Both of these are tetrahedral because they both contain 4 bonds. If there's a double bond in there somewhere, it's going to be planar. Okay, so I'm going to rub that one out there now, because we don't need it anymore. So it says name the molecule, so drawing it's not good enough. You have to write down the name of it, so it's going to be ethene. Next, B. B is asking us for identify an addition reaction and a substitution reaction in the reaction above. Okay, so look, I'm just going to write down I and II. And I think we have I is addition, so I'm just going to write down addition. And I2 is going to be substitution. So let's go back up here and have a look. So X, Y, or Z has to be, or W for that matter, have to be addition or substitution. One of them. Okay, so let's have a look. Again, you're just going to compare the difference in terms of molecules. So if we look at X here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 atoms over here. And if we look at C2H4, we have 6 atoms here. So X is an elimination reaction. Okay, so it's no good. If we're not asked for an elimination reaction, we're asked for an addition or substitution. So X is not going to be the answer. Let's look at V. Let's just go straight down here. We have 6 atoms over here, and over here we have 8 atoms. So V is going to be an addition reaction. So all I have to do over here for addition is going to be V. Okay, so we know V is our addition reaction. Let's look at Y. We're going from C2H4, so that is 6 atoms on this side. Over here we have 2 plus 5 is 7, plus 1 is 8. So Y actually is also an addition, reaction. So V and Y. So Z has to be our substitution, but we'll double check it. So we're going from, Z is this way, so we're going from 2 plus 6 is 8 atoms here to 2 plus 5 is 7 plus chlorine. That gives us 8 there, so Z is our substitution. Grand. Let's look at C. Oh, I skipped out C actually, didn't I? For some sort of reason, probably a mechanism. So we're actually going to move on to D. State the reagents and conditions used to bring out conversion I and II, so that's V and Z. So I and I. Okay, so we already said that V is our addition. Okay, so this is addition here, and Z is our substitution. So you have to go back to your mechanisms here, guys. Okay, so for an addition mechanism, and again we'll go over here to V. You're going from ethene to ethane. Okay, so all you have to do is find out the difference between them, and that's it. So in this case here, it's going to be, if we're looking at it, it's just going to be 2 hydrogens. That's the difference between here and here. So therefore, for that conversion for V for part I, okay, it's simply going to be H2. So H2. Okay, that's it. Now, it's asking for 2 things, don't forget, the reagents and conditions. So if we look at Z, for any substitution reaction, okay, it's always the same, guys. Like, if you look at it, it's going to be chlorine, Cl2, plus ultraviolet light. That's your mechanism there. So we write down Cl2 and ultraviolet light. Okay, and that's it. Okay, Cl2 and ultraviolet light, and that's always the way for substitution mechanisms. Okay, F. We skipped out E there, you can see, so we're going to go on F, and that's the synthesis of PVC. Okay, so I said I'd just throw that in simply because it's not asked too often for the mechanism of it. Now, you're actually not asked for the mechanism, you're actually only asked for the structures of the organic intermediates. So that's what I'm going to do now. Okay, in the synthesis here, I'm just going to draw them out. So the first one is going to be 1,2-chloroalkane, or ethane to be precise. And the other one then is going to be chloroethene. Okay, so I said I'd just put that in, and if you want to see the exact mechanism, you'll see it on the Konica flask. Okay, so they're the 2 intermediates there in that synthesis for PVC, and that is 1,2-dichloroethane and chloroethene. So look, we'll move on to the next one, so guys. And this is 2007, okay, that we're dealing with now. So 2007A, let's have a look. Name the homogeneous series which A belongs to, and also which to C belongs to. Okay, so let's have a look at A. Count up the number of carbons. So we know there's 2 carbons present, so therefore it's going to have S at the start. And I'll just do I here, and II. So S is going to be the start, that's fine. Now, do you see how there's twice as many hydrogens as there is carbons? So in that case here, it's going to be ethene. If it's an alkane, there'll be twice as many, plus 2. So let's look at part 2 now, and we're looking for C. Oh, we're looking for C there, and we have a CHO at the very end of it. So straight away, I know it's going to be an aldehyde because that's where the functional group goes. We count up the number of carbons. There's 2 there, so therefore it's going to be ethanal. So ETHANAL. Okay, that's that part done. Let's look at B. So B, the conversion of B to A, so that's B to A here, is an elimination reaction. What 2 features of elimination reactions are illustrated by this conversion? Now, the way that was phrased was poor enough, okay, and it can actually confuse people. So what I'm going to do there is I'm going to draw out both of them just so I can explain where each of them is coming from. Okay, so we're going from an alcohol, a primary alcohol for that matter. I'm going to do my OH here. Again, I'm putting in all my bonds. And we're making it into an alkene, so that was this guy over here. Okay, So what the question is, what two features of elimination are illustrated in this conversion here? Okay, first off, the first change is you're going from tetrahedral to planar. That's the first feature, okay, that we're coming across. Now, and again, just tetrahedral parts, because there's each of the carbon atoms here have 4 bonds, 4 single bonds I should specify, whereas over here there's obviously a double bond there present, so that's not good. And then the second thing, and the most obvious one, is that you're losing, if we look at the difference between over here, you're losing H2O minus H2O here. So the loss of H2O. Okay? So there are your two features there. The first one though was the trickiest one because students missed that part of it there. Okay, that you're going from tetrahedral to planar. That's it. Okay, let's look at C. Okay, so C says name the reagent the catalyst converts C to B. So C to B is going from an aldehyde to your primary alcohol. So it's a reduction reaction. And again, the hint there was you're given a catalyst. So in that case there, it has to be your H2 and Ni. And if you want to say that the Ni is a catalyst, you can. Let's look at D. D. Draw the full structures for B and C. Indicate any carbon that has a planar geometry and list the bonds broken in B and C in the synthesis of C from B. Okay, that's just a bit of a mouthful there, really, isn't it? Okay, so let's just draw B and C first. Okay, and get that over and done with. So B was the alcohol, and I have it here, so I'm just going to make that a little bit easier. Thank God for notability. So this is B. And I'll draw my C next to it over here. So this is C. Okay, so what's the first part of the question? This just breaks up into bits. The first part there says draw the full structure formulas for B and C. Grant. I've done that there now. Okay, for B and C. And again, if you're asked for the full structural formula, and I can't stress this enough, make sure you put in the bond between oxygen and hydrogen there. Next, I indicate any carbon atom in either structure as planar geometry. Okay, so what's planar here? Well, there's only one carbon atom that's planar, and that's this carbon atom here, because it's the only one there that has a double bond. So I'm just going to make a note of that there for me. Carbon atom. It's the only one, okay, because there's a double bond present. The rest of it, and this molecule over here, the alcohol, doesn't have any planar atoms either. Okay, list the bonds broken in B and the bond made in C in the synthesis of C from B. Okay, so we're making C. So what was C? The aldehyde there. So I'm actually going to redraw this again. Over here. So we're making, and we're making C basically. And again, that was just the way it was worded. It was poor enough to try and figure things out. We have enough to be doing now than trying to figure out what the question actually means, as lone answers. Okay, so I'll read it again because it really does need to be read again. In synthesis of C from B, so that's fine. We know it's going from, we're making C. So list the bonds broken in B and the bond made in C. Okay. So we have our B over here. We have our C over here. So what bonds have been broken in B? So if we're looking at it, we can see here that the OH bond is broken. So we'll say bonds broken. Bonds broken. So the first one being the OH Next one, is there another bond broken? There is. If we look at this over here we have on this carbon atom here has two hydrogen atoms it's bonded to. This carbon atom over here only has one hydrogen atom. So therefore a CH bond is broken too. And then over here we're looking for what was the one bond formed? There's actually only one bond formed. And that's going to be the C double bond O. That's it. Again, there's actually a bit of a hint up here. You're told in this one over here that list the bonds broken, bonds being plural, okay, and the bond, okay, being singular there. So that was a clue that there was actually more than one bond being broken in B. And again, if you hadn't drawn out the OH over here like this, you probably would have missed it. Okay guys, let's have a look at E. E goes down here, nearly there. So for E, after carrying out the lab conversion there of B to C, how could you test the product to show that C was present? Okay, well there's actually a couple of different ways you could do it. Okay, if we oxidize C, we're going to make ethanoic acid. Okay, C being ethanol, so we oxidize any aldehydes, we get ethanoic acid, sorry, carboxylic acid in general. So what could you do? Well, there's a couple of things you could do. You can add in feelings A and B plus your aldehyde, and you'll get a bit of heat, and it'll go from blue to a red precipitate. So that's what we set up above here early on. If I can find it. Oh yeah, here it is. So feelings A plus B, your aldehyde and a bit of heat, and it goes from blue to a red precipitate. Okay, that'll prove that you have that in your test tube, that you have C in your test tube. Okay, now you could do other ones. Okay, there is other ones there. There's Tollens reagent. You could have done that one too. Okay, then there's probably is more than that. But that feelings A and B is kind of the easiest one to remember. Acidified potassium manganese is there too. So let's continue on with F. So I'm not going to do out E or read it out. Sorry, I'm not going to write it out, I should say. I just called it out there. F. Compound C is formed as a metabolite of compound B in the human body. How does compound B come to be present in the human body? Well, B is ethanol over here, and ethanol is the only drinking alcohol there. So you literally just, I'm going to get rid of E there. You literally just need to say drinking. That's it. Okay, for that one over there. So we've done A to F there now, guys. Fairly straightforward. It was a nice question actually overall. And again, you just have to be as thorough as possible with that. So look, we're going to do, I think this is the last one actually, 2003. Okay, so we'll fly through this one here, hopefully. We're starting to see that there's a lot of repetition in the questions, which is nice. So A. Which of the compounds A, B and C has no tetrahedral bonded carbon atoms, and to draw the structure of that? Okay, so again, if it has no tetrahedral carbon atoms, okay, it cannot be an alcohol or alkane or a chloroalkane. Okay, so C2H6, okay, is going to be our alkane, so that's no good. Our C2H5Cl is a chloroalkane, so therefore C2H4 has to be the only one. And double check it, okay, that's why you can draw it out. Okay, so A stands there, and we'll double check it by drawing that out, and this is what you want to get. No tetrahedral bonded carbon atoms here for etene. Okay, so we've drawn structure and we've named it there, so let's go on to B. And I actually didn't name it, but I don't think you had to. I'll just do it anyhow. Classify X, Y, and Z as an addition, substitution, or elimination. Well, we've practiced a few of these already. Let's look at X. So again, count the number of atoms either side. We have 6 atoms over here. Over here we have 8. So X equals addition. Let's look at the next one. For Z, we have 8 atoms over here. If we count them over here, we have 2 plus 5 is 7, plus 1 over here is 8. So therefore, Z equals substitution. And last but not least, we're looking at Y. We have 6 atoms over here, and over here we have 2 plus 5 is 7, plus 1 there, and that's going to be our 8. So for the last one then is going to be our addition. And that was what? That was Y. Okay? And that was all. Now, students get thrown off there because there was no elimination in it, and they thought that, oh, there'll have to be elimination there somewhere, and that was a bit weird getting 2 additions. That's not necessarily the case, so just be careful with that, okay, guys? So we have 2 additions and 1 substitution for that one there. C. What reagent is used to convert A to C? So A is over here, and C is down here. So we're going from ethene to chloroethane. Okay, so again, identify if it's a substitution or addition. In this case here, it's going to be addition. Okay, so go back to your addition mechanism there, and what did you need to use? Okay, for this. Okay, so A to C there. We can see there that we're going to need, if it's addition, we're going to need 1 chlorine, and if we're looking at it, we have a hydrogen over here extra compared to over here. So HCl is going to be our answer. Hydrogen chloride is the name of it. Okay, so that's A to C there. That's the answer for that one. And our last one now is D. What reagent and conditions are required for B to C? As soon as I see that, like what reagent and what conditions, I know it's going to be substitution. And we'll just double check it to be sure. So B over here, so C2H6 going to C2H5Cl, so that is substitution. Okay, we set it down here anyhow. So again, it's always the same for this, guys. Okay, your reagent, and you want to specify which is which. So that means reagent equals chlorine, so that's Cl2, conditions equals ultraviolet light. And that's it. So guys, look, I'll just double check there, that was it. Yeah, it is. That's the last of our organic synthesis. Like you can see, there is a fair bit of repetition between the questions, and I got rid of some of them because I didn't do every single year, so because they were so repetitive. Now I didn't do mechanisms in that, and I didn't really specify or go into any detail on the theory parts or the esters. So just to be careful with that. So yeah, that's it really for the organic synthesis. And again, they come up every year more or less, so it is something worth knowing. And just take it logically and step by step, and you'll be fine. Okay, everybody, I hope that helped.